Hi there, welcome to Xamarin University. My name is Mark Smith, and in this video we're going to talk about an introduction to Xamarin.iOS. Our goal today is to broadly introduce you to Xamarin.iOS and how to build a basic application using either Xamarin Studio or Visual Studio. We're going to cover three main points today. First, we're going to go through the development tools. Now, we won't be setting them up today. That should have already been done in Xam101. So we're going to be focusing on what tools you use and the styles of iOS applications you can build using the pre-supplied templates. Then we're going to pick apart a basic Xamarin iOS application and talk about all the source files and what they do. And you're going to see how the tools turn your code into an iOS application and how you can then run it on the simulator or on a physical device. And finally, we're going to get to the meat of the course and talk about how to create a screen in an iOS application by adding controls to it. We'll discuss basic positioning and how to add behavior to the application, and as part of that, you're going to build a simple tip calculator. So let's go ahead and get started. We're going to start by discussing the development tools that you're going to use to create your first application. So to do that, we're going to talk about exactly what Xamarin iOS is and how it relates to the operating system. And we're going to talk about the different IDE choices you have, so what your development environment will typically look like. And then finally, we're going to look at all the different project templates that come with both Xamarin Studio and Visual Studio and see how they differ. Now, as you probably remember from Xam101, in order to build a Xamarin iOS application, you need a Mac running the latest released version of Mac OS X. That Mac's going to need the latest released version of Xcode, and you're going to have the Xamarin tools installed on it. Apple requires that developers upgrade to the latest versions of pretty much everything, and the Xamarin tools are updated to match, and so we recommend that you keep Xcode up to date and update to the latest Xamarin stable releases as they're pushed to the stable channel. You should have gone through some of the setup process and validation steps when you took Xam101. If you've not set up your machine, I recommend you stop the video here and go watch that video, particularly the last parts of it, in order to see how to set up your machine, get it all configured and ready to go, and then come back to this video. So I'm going to proceed with the assumption that everyone has their development environment set up. So let's talk about what's installed. First, what is Xamarin.iOS? Well, Xamarin.iOS is based upon the open source Mono project. For those of you that aren't familiar with Mono, it's an open source, cross-platform implementation of .NET. It runs on Mac, Linux, and Windows, and it's completely separate from the one that you would get from Microsoft. Xamarin.iOS is a mobile implementation of that specifically designed for the iOS operating system. And it layers on top of the native operating system controls and frameworks that are supplied by Apple. And it allows you to use your C# skills to be able to program your iOS applications. As you can see in this diagram, your application code sits on top of the Xamarin iOS runtime and the framework libraries that are supplied with it. That runtime provides direct access to Apple's frameworks and iOS through binding layers. These binding layers are very similar to the pinvoke layer that you use in .NET Windows development. And they allow your C# code to transition into the native platform and coerce all the parameters that you use to pass back and forth between the managed side controlled by Xamarin iOS and the native types that are actually used by the underlying operating system itself. As you'll see in a moment, all of this happens transparently to you. Your code will simply derive from and use the native types as if they were natural C# things. Several other things were installed when you installed the Xamarin tools. First, you got a cross-platform C# compiler that's fully compliant with the latest C# specifications. You got a subset of the .NET Framework class libraries based on the shipped 4.5 assemblies from Microsoft, and in some cases 4.6. You got a runtime engine which will provide security, interop capabilities, and garbage collection services to your application, and an optimizing native code compiler and linker which is used to create the native code that Apple's tools will expect to work with when you run it on a real device. Finally, you got all the binding definitions for all the released iOS APIs. Now, I say released because beta APIs aren't completely supported because they're under NDA. You'll see them start to show up in the alpha channels, and once iOS 9 or iOS 10 or whatever comes next is actually released, typically Xamarin has support for it on the day of release. So you have two IDE choices available, and we covered this in Xam 101. You can use Microsoft Visual Studio on Windows. We support Visual Studio 2012 and above today, including the free Community Edition of 2015. In fact, if you use Visual Studio 2015, you can actually install the Xamarin tools right from the Visual Studio Setup installer. Older versions of Visual Studio don't include Xamarin directly, and so you have to run an independent installer to get all the tools. Now, if you'd like to use Visual Studio on Windows, remember that it will require a business license of Xamarin. And you'll still need a Mac with Mac OS X and Xcode plus the Xamarin tools installed to be used as a build host. You can also use Xamarin Studio on Mac OS X. Xamarin Studio is a customized version of the open source Mono Develop IDE. And it looks and behaves very much like Visual Studio. So if you're already familiar with the Microsoft development tools, you won't have any trouble transitioning to this IDE. Xamarin Studio can be used with any Xamarin license, including the free Starter Edition. For both IDEs, we recommend that you run on the stable channel and stay up to date. Now, one quick point I want to make here. When you install the Xamarin tools on Windows, you will get a version of Xamarin Studio on Windows as well. However, it does not support iOS applications. It's only capable of working with Android applications on the mobile side, and then it has a few other projects for console apps and web apps. Now that we've gone through the tools, let's talk about starting a new application. No matter which IDE you decide to use, your application adventure will begin with File New Project. Both of these IDEs have a set of installed project templates to create iOS applications with a few different styles. And your app creation experience is going to be a little bit different depending on whether you're using Visual Studio or Xamarin Studio. Now, you're going to create an app in just a moment, and the lab exercise will walk you through either IDE, but let's first talk about the project styles you can start with. The first project style we're going to focus on is the single view application. This is the simplest project template available, and it's the one that we're going to use today. It creates an application structure with a single empty page declared in a designer file that's ready for you to add controls to. Many applications will begin with this template. The second template you can use is the Master Detail app. This creates an application with two views. The first is the master list of scrollable records, where each record represents some piece of data in your application. The second screen is a detail view that shows the details for one of those records. And so the idea is you can tap on a record in the first view, the master view, and then either update or navigate to a second screen to display the details for that record. So some examples of applications you might be familiar with include the Mail app, the Reminders app, and the Contacts app. All of these apps built into iOS use this paradigm. The template also supports a combined master detail view on tablets in landscape mode. And so if you turn the tablet in landscape mode, it can actually present both the master and the detail views simultaneously on the same screen. For data-driven applications such as emails or tasks, this is a great template to start with. And we do cover this template in detail in the iOS 205 Navigation Patterns course. Next, we have the page-based application. This creates a single screen app that lets you swipe through different pages of information, sort of like a book. For example, the PDF Reader or the Kindle app or the Nook app would all be examples of this type of application. If you're trying to build an app where the screen remains consistent but you're swiping between pages of related information, then this might be a good starting template to use. Next up, we have the WebView app template. This creates a hybrid application which hosts an HTML web view control. The content is locally shipped with your app as ASP.NET Razor pages. It's not server-based, it's all local content. And this is a good choice if you have a significant investment in HTML and CSS, but you'd like to build a native application that you can deploy through the App Store. The last template choice is the tabbed application template. This creates a multi-page application where each page is a tab with a button representing it on the bottom of the screen. For example, the built-in phone app in iOS uses this paradigm, as does the music application. If you're building an app with multiple distinct pages that may or may not have relationships, then this is probably the template for you. As with many of the other choices, we covered this template in the iOS 205 Navigations course. So if you're interested in learning more about the structure of these applications, then make sure to take that course. Now, one thing you might notice if you're using Visual Studio is that there are 3 iOS categories: iPhone, iPad, and Universal. These correspond to the devices that you'd like to target with the application. iPhone and iPad are specific to that device style. So, for example, iPad would only run on an iPad device. iPhone is targeted for iPhone, and so all your assets are scaled for the iPhone, and can run on an iPad, but do it by simply blowing up the UI, and so it's not an ideal view for the application. The third form is the Universal template. This creates a single application which can be run on either an iPhone or an iPad. And the way it works is the template creates 2 UI definitions, one for the phone and one for the tablet. You share all the logic and the code between them, but the UI is defined independently. Now, this is an older approach to creating adaptive designs. And as of iOS 8 and beyond, Apple doesn't use this approach anymore, or at least I should say, they don't necessarily recommend it for most applications. You can totally still do it this way, and it does work, but now they have some new features in the API itself to help you create adaptive UI that will then automatically adjust based upon the size of the screens. And since we now have several different variations for phones and a couple different variations for tablets, it's probably a good idea to go ahead and start leveraging those APIs rather than use this approach. But this is what's available today in Visual Studio. Now, a future update of Visual Studio is going to look a little more like Xamarin Studio with a wizard that will then prompt you for some of these things. And so you'll see some of these categories potentially will disappear in the future. But this is what it looks like as of September of 2015. So let's go ahead and use one of these project templates to create an application. So this is the Start Here file that comes with your materials. Here you can get the slides themselves, so you can go through the PDF that includes all the slides. And what we're going to do right now is this first exercise, creating your first iOS application. So I'm going to click on Exercises, and it's a very short exercise. It won't take you very long. But the idea is you're going to create a single view application using the project template in either Visual Studio or Xamarin Studio. You'll name the app Tip Calculator, and that's all you'll do. So you'll just walk through the project wizard. Now, in the detailed steps here, you can either select Xamarin Studio or Visual Studio, and you can see that the instructions will actually change because the experience between the 2 IDEs is slightly different. So go ahead and stop the video here and work on this exercise and get your project created, and then we're going to walk through the project together. So we've seen now what Xamarin.iOS is, and we've explored the different IDE choices, Visual Studio and Xamarin Studio, and what's required to use them. And we've built an app using the single view app template. So let's move next and actually deconstruct that application template to see exactly what components were added into the project and what they do. So we have a couple of goals. We're going to break apart the tip calculator that you just built. Now, as part of that, we're going to have to discuss a few things that Apple defines, some terminology that Apple uses in terms of their application process. So we're going to talk about a design pattern called Model View Controller, and we're going to talk about how you can build your application, compile it, and what happens during that compile step, and then finally how we can execute the app. So before we start exploring the project, there's several interconnected pieces that I just want to touch on, and then we'll look at the project directly and see how they're all put together. Your project's really going to have 3 things in it. The first is, of course, your C# source files. You're going to program all of your business logic and all of your data representations in C#, and so you'll have a bunch of C# source files to represent this. It's also possible to create UI definitions in C#, and so you can construct screens by creating controls in code and then add them into your views. However, most of the time we use declarative files for that. Your UI definitions are stored in 2 types of files in your project: storyboard files and zib files, or XIB files. These are Xcode Interface Builder files, and these 2 file formats are basically Apple's designer formats. Now, we aren't actually going to use this today. Instead, you're going to take the second half of this course, iOS 102, where we'll talk about the designer and how to then use the storyboard file that's been added to your project. But just be aware that these are designer files that are used to represent the screens that are in your application that you can interact with. The last type of file that you'll find in your project is metadata files, or property lists. These have the extension of plist, and they're essentially XML key value pairs that describe additional bits of information that are necessary for the application to run. And so we'll see two of these files in your project form when we look at it in just a moment. So let's go ahead and create a project and then walk through all the pieces together. The printed PDFs that you have with the materials actually have all of this content as slides as well, so you can look through the slides if you're interested in seeing some additional details about the files that are in your project. So here I am in Xamarin Studio on the Mac. I'm going to start on the Mac and create a project and walk through it here, and then we'll go and switch over to Visual Studio and do exactly the same thing, just so you can see that the projects are very similar and you can do all of the same things in both environments. So I'm going to go ahead and create a new solution, just like your lab indicated, by clicking on the New Solution button here. And what I get is a project dialog. And notice that I can choose the type of application I want to build from here on the left. I'm going to pick iOS app, and then it lists all the project templates. These ones here at the top are exactly the ones that we went through in the slides just a moment ago. And then I have a series down below which are different game templates. And so if I want to create some kind of game, such as an OpenGL game or game that's based on SceneKit or SpriteKit, these would be the templates that I would want to start with. We're going to use the single view app template today, and I'm going to click Next, and it's going to prompt me for the application name. I'm going to go ahead and name it Tip Calculator, just like you did in the lab. And notice that I can specify my organization identifier here. This is the name of my company in reverse DNS notation, so it would typically be whatever your web address is, or at least the corporate name with the .com extension in reverse form. So com.xamarin is what we use. And that's used, these two values, app name and organization identifier, are combined together in order to create what we call the bundle ID. The bundle ID uniquely represents your app to iOS. And so this is just a string that's going to represent your application both to Apple on their portal. So when you register your app with Apple and you go to deploy it through the App Store, this bundle identifier is actually going to be known to Apple. So it's going to be unique to both your organization as well as your application. So this has to be a unique value. And then I can decide what devices I want to support. So I'm going to uncheck the iPad device and just leave iPhone checked. And I can pick my minimum version. So I'm going to go ahead and leave it as 8.4. That's the latest version as of September 2015. Then I click Next. And notice my last dialog here, I can select the project name and the solution name if I'd like them to be different. It kind of shows me a preview of what the solution is going to look like here. And I can pick the location that I want to put it. So I'm just going to place it on my desktop. That's great. And then we have some optional things here we can select. So I can go ahead and create a get version control repo. So this would be a local repo that then I could maybe push to a remote, like GitHub or something like that if I wanted to. I can then integrate two optional products from Xamarin. And these may be checked if you've ever used these in the past when you created an iOS app. But the first is Xamarin Insights. That's our analytics tool. And so if you check this, it will automatically add the assemblies necessary to integrate with that. And then you can start adding in support to be able to track your users, track crashes, be able to see your user base and what screens they're using and that sort of thing. We're going to leave that unchecked today because we're not going to cover Insights. The second one is Test Cloud. This allows you to start creating acceptance tests or UI tests. And so by checking this, it will add in the appropriate assemblies to be able to drive your application through automated tests. And it will add a second project to the solution that'll be a starting UI test project. Again, I'm going to leave this unchecked here because we're not going to be using any UI tests here. But if you're interested in either one of these technologies, we do have classes in Xamarin University that cover these topics. I'm going to go ahead and click Create and let the IDE do its thing. It's going to end up creating a solution with a single project in it. Now, if you're not familiar with those terms, the solution is simply a grouping of projects, and so we can have one or more projects inside of a solution. and the solution will maintain the build order. So often projects within a solution have some kind of relationship. There's a dependency from one to another. And so by indicating what that dependency is to the solution, we can make sure that the projects get built in a specific order. So the compiler builds them in the correct order to make sure that everything is up to date. We only have one project in this solution called Tip Calculator, and the project and solution formats that we're using here match what's used in Visual Studio. And so if you'd like to switch back and forth between the two supported IDEs, you totally can do that. I could take this project, copy it over to a Windows machine, open it up in Visual Studio with the Xamarin tools, and be able to do all of my editing there if I wanted to. Inside the project, if you're a Microsoft developer, you're going to find similar things to what you have in any other .NET project. For example, we have a references folder, and here you can see the assemblies that this particular project depends upon to both compile the project as well as run it. And so we can see some common assemblies here, such as system, system core, system XML. These are all just regular .NET assemblies that you probably are familiar with. And then we have Xamarin.iOS. So Xamarin.iOS is what uniquely identifies this project as an iOS application. Xamarin.iOS is the equivalent of MS Core Lib if you're familiar with the desktop or the web environment. And so by including this becomes our runtime target, and it's what includes the runtime engine, such as the garbage collector and system types like string and integer and stuff like that. So all of that's contained inside this DLL component here. Anytime that you add a project, or rather a dependency, another reference into this folder here, so notice I can right click, say edit references, any reference that I add here has to be a Xamarin.iOS built DLL. In other words, the assembly either has to reference Xamarin.iOS or it has to be a portable class library, one of the two. But we can add new references in here. So if I wanted to be able to support something like SystemNet HTTP, I could simply add a reference here, say OK, and then notice that now I have SystemNet HTTP. So this again is just a standard .NET framework assembly. So references works exactly the way you expect. Then we have two components folders. The first is just components, and this is related to the Xamarin Component Store. And if you right click, you can go get more components. It'll load the component store. I can pick a component that I'm interested in, and then I can simply add it to my app. Notice that this component here is actually free, so its price is free over here, and it's supported on Android, iOS, and Windows Phone. So the component store is managed by Xamarin, and you can publish components to the component store that are either free or you can support a pricing scheme on them. And so we support both commercial and open source or free components as well. Packages is for Microsoft's distribution mechanism, which is NuGet. And so if I right click on this, I can add new packages. And notice that, for instance, if I were searching for Azure Mobile Services, that it actually exists here in NuGet as well. And so if it's in both places, I would recommend that you actually prefer NuGet over the Xamarin Component Store. Typically, NuGet gets updated a little more frequently, and often, in fact, the Xamarin Component Store will simply defer to NuGet. So if you add it through Xamarin Component Store and it's available in NuGet, there's not even a valid DLL or assembly in the Component Store. It just downloads a shim that then tells it, hey, go download this from NuGet. And so if it's available in NuGet, I would recommend just using NuGet. The downside to NuGet, or rather I should say the only restriction to NuGet, is it doesn't support commercial components. And so if you want to sell your component, then the Xamarin Component Store is a better model for that. But anything that's free, and that's a lot of stuff in .NET, you can download through NuGet. Now, one point about that, the component that you download either has to be portable, so it has to be a portable class library, or it has to be built for Xamarin.iOS. There are plenty of components out there, and most of the very common ones, like, for instance, JSON.NET, support all of the different platforms. But you can go look at the component just to see if it's supported for your platform. And if you try to add it, and it's not supported, then you'll just get an error when you try to actually add it to your application. So it'll tell you that it's not actually supported. The next directory we have is resources. So this is where all of your image assets are going to end up in iOS. And there's two different file formats that you'll find in here. One is just standalone images, such as PNGs or JPEGs. And there's a naming convention that Apple uses for them to be able to indicate what resolution they're at, so that you can then deploy the app to both lower resolution devices as well as Retina displays, or just larger displays so that your icons all get bigger. The naming convention is all described in our publishing class today, but essentially it's the low resolution image, or the regular image, is just the file name itself, And then once it's a Retina display, it goes to @2x, so they use the @ sign and then a 2 and then an x. And so that's the suffix added onto it. So for instance, it would just be image @2x.png as an example. And then there's also an @3x that's used for the iPhone 6 Plus. Again, we go through all of that in publishing, and so you can go watch that class or go take that class and be able to see all of that. The newer way that we actually manage that, though, is what we call image assets or asset catalogs. And you can see one of them here. This is the app icons. And so if I double click on this, you can see there's a contents.json here. And if I open this up, it allows me to then assign different images to my application structure. And so these images are what iOS would then use to represent my app on the Springboard launch screen or in Spotlight or in settings or something like that. And you can see that it's even telling you how big the images are supposed to be. And it's showing you 1x, 2x, 3x. And so these are the suffixes that we would normally have on the image, except we wouldn't put a 1x on there. That would just be omitted. But it's showing me the scale for the image that we're interested in. And so you can just click on these and then go find the image and say, add that image in. You can create multiple image assets. And so notice I can add new image sets in here. And then I could add in my own images that would also include multiple resolutions. And this is the more modern way to kind of manage your images. Then we have a launch screen, and the extension here is Zib for XML interface builder. And so this was a file that represents a single screen in your app. And this is actually kind of interesting because launch screen is a new feature of iOS 8, and it allows us to have kind of a splash screen that's adaptive so that it stretches to fit whatever the current device is. And that way you can use the same screen all the way back to an iPhone 4S up to an iPad display. And I'm running an alpha build of the Xamarin Studio here, and so I'm on the alpha channel, which is a little bit dangerous. I don't recommend it for most people, but the reason I installed the alpha build is because it has a new feature in it that I wanted to show you here, which is the ability to edit these zip files. And so the designer now supports editing of zip files, which is awesome because now you can just come in and change things like the launch screen here and say, I want this to actually have, for instance, a space in it. And so now it's got a space in there, and then I can change the copyright if I wanted to. And so we can edit the launch screens now, which is great. The next file that we have here is this app delegate, and it's the file that was opened when this project was opened in Xamarin Studio. I'm going to skip this one for just a minute because I want to move to this other source file that's in here, main.cs. And I'm going to open this one up instead. Now, main.cs, as you might expect, is your main entry point from iOS. So this is the first piece of managed code that executes, just like every other .NET program that you've probably worked on. And notice that we have a single class here called application with an entry point of static void main, just like you would in any other .NET app. We get some args, and the only thing that this main application does is call a built-in method in iOS called UIApplication.main. Now, this is what's going to launch the UIKit framework. UIKit is Apple's UI system. It's what contains all the controls and kind of runs the processing of the screen. And so what we're doing is we're sort of jump starting that by calling this main method. We pass the arguments. We pass in a second parameter that allows us to designate a special class that's used for our application class. We're not using that here, and the template doesn't do that, but you can support it if you want. And then we have this third parameter, which is just a string of app delegate. Now this is pointing to this other file here. Notice that they're the same name. And so this app delegate file is actually a special class that derives from a special class in UIKit called UI Application Delegate. We're going to talk a lot about this in just a minute, but let me just point out that this class here there's only one of them, and the system creates it for us. So when we call that UI Application main, it's going to create this class for us because we pointed it at this class, and it does that through this register attribute. This string here has to match the string here, right? So it's not really the class name per se, although by convention we always keep them the same because it would get a little confusing if you start having those two things be independent. And so generally speaking, you want those to be the same. But that's what's tying them together. And so that UI applications main is going to create one of these, and it's going to link it into iOS. And so as iOS needs to notify our application about various things that are happening to our app, it's going to call methods on this class. That's the purpose of the app delegate. It's kind of a way of doing system notifications from iOS into our app. And so we'll talk about all those notifications in just a moment. Now, the next file that we have in here that's a source file is this viewcontroller.cs. This is the controller portion of our application. We're going to talk about model view controller in just a moment. But the idea is this is where the behavior of our application is going to go. And in fact, in the next lab, you're going to actually remove all of this code, and we're going to build this up from scratch to be able to kind of build up some UI and do some different things. And so we'll get rid of a lot of the stuff that's actually here inside this view controller to be able to kind of manage it on our own. Now, you might be asking, well, if the UI right now is not being declared by that, where is it being declared? Well, it's being declared through this main storyboard file. So remember, normally when we create UI in iOS, we'll use a declarative form. And the storyboard is really the most modern way to do that. If I double click on this, it'll open up in the same designer that we used for zip files, except the big difference is that in the storyboard designer, I can have multiple screens. And so notice that I have a single screen definition here for the main screen that we're going to use, but I can actually create multiple screens, and then I can create relationships between them through the storyboard. We're not going to use this feature today. Instead, I'm going to go ahead and defer that to IOS102, which is the second half of this class. And we'll cover the designer in all of its gory detail at that point. The last two files that we have in our project here are entitlements plist and info plist. These are the two metadata files that I described earlier. So entitlements, if you double click on it, will open up a nice little GUI here that you can edit the file with. And notice that it's how we enable things like iCloud and Passbook and Apple Pay and in-app purchases. These are Apple services that our application can take advantage of, and we have to register both with Apple and we have to notify it in our entitlements plist. So the entitlements plist will make sure that the App Store tells the user, hey, this app integrates with iCloud, or this app uses Apple Pay, or something like that. And it ensures that our application tells Apple what our expectations are in terms of being able to use services. The second file that we have, info plist, is actually describing the metadata for our application itself. And so notice that it allows us to change the application name. This is the name that's shown on the Springboard launch screen of your iPhone. We can change the bundle identifier if we don't like the one that got created for us. We can set the version, we can change what devices are supported, what devices we can run this app on. We can change the deployment target, and so if I want to be able to run my app on a lower version or an older version of iOS, I can change this. Be aware that if you change that, it's going to restrict the APIs that you have access to. And so the deployment target itself says, what's the minimum version of iOS that my application can run on? And that means that if you use a newer API that was created in an older in a newer version of iOS, then you're going to have to make sure to put if conditions around it and only use that API if you know you're on a version that supports it. Okay, so be aware of that. Most of the time, Apple kind of just requires that you build against the latest SDK, but you can set the deployment target to whatever you want so that you can run on really old things. Then we have some ability to change device orientations. You can see this is where we can identify our app icons. And then we have some other spots here for launch images. So this is the older way prior to iOS 8 that we would create launch screens. So today the new model is to use these launch screen zip files. Those are adaptive so that way it runs the same way on every device. These launch images were different sized images, and so you included an image for every possible device variation that you might encounter. And so that just meant generating a whole bunch of different images, which bloats the size of your application. Launch screens, the zip files, are a much better approach to this. And so we typically don't supply these unless we know that we're going to be running on a version of iOS older than 8. And so if your app is capable of running on iOS 7 or earlier, then you'll want to make sure to include launch images because it's not going to look at your zip files. So that's the project structure in Xamarin Studio. Let's switch over to Visual Studio and see what it looks like over there. So here I am in Visual Studio, and all I've done is launch this. I'm on Windows 10, and I'm going to go ahead and create a new project. Now notice it pulls up the regular Visual Studio project dialog here. And so we don't get the nice wizard walkthrough that we had in Xamarin Studio, although I expect that we'll eventually have that in Visual Studio as well. It would be nice to kind of have some synergy between the two environments. But today it's just the standard Microsoft supply dialog, and so we just have categories here. So there's an iOS category with different devices that we can deploy to. I'm going to go to iPhone, and I'm going to select my single view app just like we did when we built the tip calculator over in Xamarin Studio on the Mac. Now notice we've got all the same templates here. They're just sort of organized a little bit differently. And we do have one template that wasn't actually available in Xamarin Studio. That's the blank app template. This is a deprecated template that's no longer available from Apple, and it's no longer available in Xamarin Studio, but it's still listed in Visual Studio. So expect that that template will go away at some point. But essentially it creates an empty application with nothing in it. So it's just one that you can start adding whatever you want in there. And so we're going to go ahead and create a tip calculator, just like we did over in Xamarin Studio. And so that will then go and let the IDE create our project. And so here we are. And I've already connected this device to a build host, and so you can see it starting my Mac agents down here. Again, I'm running on alpha builds, which include the new Xamarin build host, or what we're calling the Mac agent. And so that's a new way of actually accessing it. It doesn't require the app to be run anymore. Instead, it uses an SSH login. And so it created my app here. And notice that the project structure looks pretty much the same. I have my references here, just like we did before. We've got analyzers here, which is a Visual Studio feature. We've got asset catalogs, and so this wasn't there before, but this is similar to the resources that we had here. And so notice we don't have the resources listed, the asset catalogs listed here. Instead, this would be where we could potentially define our icons. And so it's just sort of pulled out underneath. Instead of being underneath resources, we include it up here as a top level item in Visual Studio. We have a components folder. We have our resources with our launch screen, just like we did in Xamarin Studio. My app delegate is going to look exactly the same, and so you can see that my app delegate code is going to be the same. I have my entitlements plist. When I run the entitlements plist, if I just double click on this, it will open it up in a GUI editor that's going to look a little bit different than Xamarin Studio, but it has all the same stuff in it. So notice that we can turn on iCloud, and we can turn on other things in here in terms of what I'd like to be able to support: HomeKit, HealthKit, that kind of stuff. We have an info plist editor. If I double click on info plist, I can start editing a lot of the same information that was available over on the Mac. I've got a main.cs that looks identical to what we had in Xamarin Studio. I have my view controller that looks identical to what we had in Visual Studio. And I have my main storyboard. And the main storyboard has a designer here as well. So if you double click on it, it'll open up right here inside Visual Studio with a design surface. Now, it's going to be slightly slower than using the Mac directly because we have to go through that build host. But it all works, and you can do all the same things inside the storyboard editor here in Visual Studio as well. Again, I'm going to recommend that you go take the IOS102 class if you want to learn more about using the storyboards. So now we've seen both Xamarin Studio and Visual Studio, and you can kind of see that the projects are created identically. Let's go ahead and switch back to the slides and talk a little bit more about what's actually been built here. So there's several terms that you'll encounter whenever you're in an iOS application that may or may not be familiar to you. And in particular, iOS uses some terms that are also used in .NET, but have slightly different meanings when we talk about iOS applications. So let's talk about how Apple specifically defines them. So remember that Xamarin.iOS is actually sitting on top of Apple's frameworks. And so when you see words like delegate, model, view, and controller, it's very likely that these are Apple's definitions of those terms and not necessarily the .NET variation that you might be familiar with today. So to start with, let's talk about MVC, or Model View Controller. Model View Controller is an architectural pattern. It's a very mature design pattern that's been around for a long time. It was introduced back in the 1970s as part of Smalltalk, which was one of the first object-oriented languages. There are a lot of variations of this pattern that have been implemented over the years, and some of them are more familiar than others. For example, many of you may be familiar with ASP.NET MVC, which is another variation of this particular architectural pattern. And not all of them are exactly the same or do exactly the same things in each component, but they're all designed to accomplish the same goal, which is to decouple the UI layer from the behavioral layer. Now, Apple's take on MVC is a little bit different than some. And it's useful to understand the pattern because the entire API that's exposed to you from Apple is actually designed around this particular design pattern. And so everything that you do with Apple's API will often involve one of these three elements. So let's start with the model. The model represents the data that you work with. Now, this data is very arbitrary. It could be internal data that you create. It could be database data that you're loading. It could even be data that you're pulling over the web or something that you get from a web service. Generally speaking, this data will be created in C# classes, and it will all be created and managed by the developer. So most of the time, there's very little that Apple contributes to this layer. This is a custom layer that you will build. And it may even be just strings that you have in your application. That may be the only data that you're actually consuming. But for the most part, iOS is not really concerned with this part of the system. This is what drives the visualization in terms of what gets displayed, but they don't actually provide any support to manage this particular layer itself. So you can see some of the things that you might have inside this layer. Calculation functions, processing logic, persistence logic, that would all be sort of bundled into the business logic side. Data entities, so data models that we're actually using to persist information or things that we're using to track information, validation logic, some of that may be in this layer as well. But it's a little bit gray because sometimes you'll find that this layer kind of leaks into the controller layer, and we'll look at that case in just a moment. The second layer is the view layer, and this actually is probably pretty obvious to you. The view simply represents what the user interacts with. And the base class for every view that we create in iOS is a class called UI view. Now, the UI extension is kind of interesting because you'll find it on a lot of APIs. UI stands for UI Kit, which is the framework that Apple provides to do all of your user interface work. And so everything that starts with UI sits in the UI Kit framework, and that's just a library or a component library that Apple provides that you depend upon in order to create your visualizations. Now, the reason why Apple uses these prefixes, and you'll see them all over, for example, CL is core location, CG is core graphics, is because the language that most of these frameworks are built in, Objective-C, doesn't support namespaces. And so there's no way to disambiguate types based upon a grouping. And so by convention, they use a 2 or 3 letter character prefix on every class to designate exactly which framework they're part of. And so that's why we'll see this UI all over the place. In particular, as we work with a lot of these classes, you'll see this pattern repeated everywhere. Now, when we create views, we're either going to create them in code, so we'll do it procedurally where we actually create, say, a UI button or something like that, or we'll do it declaratively through storyboards or zip files. Storyboards are a newer format that let us create multiple screens and show the relationships graphically together in a single file. And so when you work with a storyboard, you can actually put all of your screens into that one storyboard. Zibs are an older format that is also XML based, but it only describes a single screen. And so previous to storyboards, which were introduced around iOS 6, we did zip files, and you had a separate XML file for every screen in your application. Apple has transitioned to storyboards because it's a little easier to manage, and you can actually declare the relationships between those screens, how the screens navigate between each other through the storyboard, and that was not possible with the zip format. But both are supported, and you can actually declare your views in either format, and they will work in your application. The final piece is the controller, and this is the interaction between the model and the view. This is always done by an element we call the controller. The controllers in iOS are always derived from a base class called UI View Controller. Now, the way this works is typically our view performs some sort of action. So the user taps on an element or slides a slider or enters some text. That notifies the controller. The controller then responds by updating some data in the model. The model then tells the controller that, hey, this data has just been changed, and the controller then pushes that data back into the UI. And so notice that these are all very segregated. This is the formal representation for this model, for this particular design pattern, where each piece has its own designated role in terms of how things are going to interact with each other. And the controller just sits in the middle, sort of delegating between the data that's being used and the view of that data. Now, be aware that the model is sometimes merged into the controller layer, particularly if it's just simple data such as strings or maybe some intrinsic calculations. For example, if I were building a calculator app, I probably wouldn't need a very robust model to be able to represent that, because all of those calculations are just done with simple mathematical operators that could be done completely inside the controller itself. You might have a model, you might not, it just depends. And so sometimes what you'll see is the model will merge into the controller. And in fact, for simple applications, such as what we're going to build, the tip calculator, there may not even be a model. It may be just completely inside the controller itself. And so this is actually a perfectly fine. There's nothing wrong with this approach. It's just that as your application gets more complex, you'll probably find that it's necessary to start creating things outside of the controller context. And it will make your architecture a little bit easier to understand and certainly more maintainable for a larger application. Now, I mentioned that all of your controllers in your applications are going to ultimately derive from UI/View-Controller. But iOS actually supplies a whole set of derived implementations that provide different behaviors, such as new navigation patterns to be able to present alerts and to be able to present other types of data on top of your application. And so in some cases, you may end up deriving from one of these more specific implementations, or even just using a view controller directly to be able to control some of the data inside your application. So let's take this back to our application. Remember that the main method calls UI application main and passes it the app delegate to launch. The app delegate is a specialized piece of code that's required in your application, and it responds to operating system events. One of the methods that you'll almost always override if you want to influence the initialization of your application is the finished launching method. And it's ultimately responsible for three things in the initialization sequence. The first step is to create the window. The window is ultimately what will allow us to render onto the device's screen. You'll always have at least one window in your application. You can create secondary windows. For example, if you plug in an HDMI or a DVI connector into your phone or your tablet and you want to render to a secondary display. The window is represented by a class in iOS called UIWindow. And UIWindow derives ultimately from UIView. And the very first thing that our finished launching method is going to do is create one of these UIWindow objects and assign it to a built-in property named window. This window property is actually part of the app delegate class, and it's required that we assign a window as part of the initialization sequence of the application. If we don't assign a window, then iOS will create one for us. And that's exactly what happens normally when you just use a storyboard to create your application's display. It will go ahead and create a window and then create the initial view controller and view to display content into that window. We're going to take over the creation here so that you can see all the actual steps that would be happening under the covers. And so the first line of code that we're going to put in finished launching is a statement to create a new UI window and assign it to our window property. Now, UI window must be passed a rectangle to define the area that it's capable of drawing into. And typically what you'll want to do here is use the entire screen. And so this is defined by a static property on the UI screen class called mainScreen.bounds. This gives you a rectangle from 0, 0 to some coordinate that defines the width and height of the screen. And so we just pass this rectangle into the constructor for UI window to define exactly what its drawing dimensions will be. Now, the second thing that we need to do here is we need to assign the root view controller. Remember that view controllers, or rather controllers, are represented by the built-in UViController class. And your application will always have at least one custom view controller that derives from UIViewController, and it will have one for any other main view or screen that you display in your app. Here we've named it MyViewController, and you can see that we've got a class that just simply derives from UIViewController that has some stuff in it. Now, we need to create an instance of this class in our finished launching override, and we need to assign it to the root view controller property on our window object. And this is what identifies it as the starting point for the app. And so the very first screen that's displayed to the user will be the one defined or controlled by this view controller. The third thing we need to do, and final step, is to make the window our key window and then return true from the method. By defining this window as the key window, it makes this window the touch input window. This method, makeKeyInvisible, is really inherited from macOS programming, where I could have multiple windows that could receive input, but only one of them is actually the main window. In iOS programming, the main window is the one that can receive touch input, and therefore it's the one that's connected to the digitizer on the screen. And this is how iOS identifies that. So these 3 lines of code that create the window, assign the root view controller, and thereby assign the view, and then the call to make key invisible are the 3 things that are required to actually get a screen up onto the device. Now you can program them just like we've done here in Finish Launching, or you can rely on the storyboard to do this work for you. So when you see the storyboard approach in iOS 102, you'll find that none of this code is actually present in your application. In fact, in iOS 102, Finish Launching won't have any code in it at all, other than a return true. In that case, the storyboard's actually responsible for creating that window, identifying the root view controller, instantiating it, and assigning the root view controller property, and then making the main window the key window. So now that we've seen all the pieces, let's put it all together and recap the big picture. So things in blue are things that we provide in our code, and things in gray are things provided by iOS. So we'll start at the main method. This is the first spot where our code executes. Main is responsible for initializing UI kit by calling UI application main. That will create the UI application in the app delegate singletons. There's only one of each of these. So the UI application normally is just a class that's inside of iOS itself, and it just gets instantiated and used, but you can provide a custom class that derives from UI application if you'd like to. The app delegate is what we provide that handles all the operating system notifications. And again, there will just be one of both of these. UI application main will also read the info plist settings and populate the UI application and other internal data structures with the metadata that's contained within it. And then it will start up the run loop. This is a message loop that processes the UI events from UI kit within the application itself, and it runs continuously on the main thread of the application. Now this is important. If you block the main thread for any length of time, it will cause your UI to freeze. And this is probably a familiar behavior because it's exactly the way almost every UI framework on the planet works today. Right? So iOS is a message-driven system, and the main thread is responsible for pumping those messages, and that's exactly what the run loop does. UI application will then call the finish launching method on your app delegate, and you saw this code that we created in the last slide. The finish launching method is responsible for creating the UI window for the device screen and assigning the root view controller to represent the initial screen. These steps can either be done in code if you want control over that process, or they can be done in an associated storyboard. So let's add a view and a controller into our application. So I'm back in Xamarin Studio on the Mac, but this code would be identical in Visual Studio. So if you're using Visual Studio, you can follow along with exactly what I do here. And there's a couple of steps that we need to do. The first thing I'm going to do is I'm going to go ahead and open up the view controller. And this is all the code that we have inside this view controller, but we really don't need any of this because we're not going to use the storyboard. And it turns out that this view controller right now is linked to this storyboard that we have here. And so I'm going to right click on this and just say remove. And it's going to prompt me and say, what do you want to do? Do you just want to remove it from the project? That would leave the file in place. Or do I want to go ahead and delete it? I'm just going to go ahead and delete it. That'll get rid of the view controller source file. And instead, I'm going to add a new view controller source file in here. It's just an empty class. I'm going to call it myViewController.cs and hit enter. And then I'm going to do exactly what that existing file already had in it. I'm just going to drive this from UI View Controller. Now, notice that it's in red because I don't have the proper namespace here. But you can use Alt-Enter or Alt-Return on a Mac, or the same key combination on Windows with Visual Studio, and then get a prompt to actually resolve this error. And so I'm going to say, go ahead and add in using UI Kit. And we can go ahead and leave that constructor in place as well. I'm just going to save that file and then close it. So now I've got my view controller. Now what do we need to do? Well, we need to go to the app delegate, and if you remember, we had 3 lines of code that we need to put into this app delegate in order to properly construct the UI. The first step is we need to create the window object, and we need to assign that to the window property. Now, the single view template already has an override for this property, and so we can simply say window equal new UI window. And remember, we need to pass in a bounds, or rather a frame for this window to be able to sit in. And so this UI window, we need to pass in a rectangle, and we're just going to use UI screen dot main screen dot bounds. Okay, that's the actual area of the main screen. So 0, 0 would be the top left, and then it's got some width and height based on the size of the screen itself. So now our window's been assigned. That's step number 1. Step number 2 is we need to set the root view controller property of the window. That's going to be set to a my view controller instance. So we just created that view controller object, that class that represents the view controller. We just need to create an instance of one of those objects, of one of those classes, and assign it to this root view controller property. That's step number 2. The last step is we need to call make key and visible. So notice there's actually a make key window as well. That would create the window but not actually show it. You don't generally ever want to do that. Normally what you'll always just call is make key invisible, or let the storyboard APIs do it for you. So now we've got these 3 statements in our finished launching, and we leave the return true in place. I want to go ahead and test this. And so I'm going to go up to the menu and I'm going to go ahead and select build all. That'll go ahead and compile the application. You can see it's building here, and it will just make sure that we've got all the code in place and everything compiles in terms of the proper lexical analysis of the compiler and everything else that needs to happen. You should get a build successful, and now we're done. So let's go back to the slides and let's talk about how we can now actually test this application. So you just added code into a class named AppDelegate. The AppDelegate is a required and necessary part of your application structure, and iOS calls methods on it to let you know that things are happening. As I said earlier, for example, when your application is launching or when it's suspending or resuming. So delegates are an important and integral part of iOS, but the term itself might be a little bit confusing because it's not the same as the .NET concept of a delegate. In .NET, a delegate is a type-safe callback or a method pointer. In iOS, a delegate represents a set of methods and properties that are used for notifications. This is actually more like an interface than a delegate in .NET. So this term of delegate you'll find all over iOS, and we use it for notifications and for behavioral customizations, where I can actually influence the behavior of a class without deriving from it. You'll find delegates all over iOS. You've seen one example with the app delegate that's used to receive notifications from iOS itself about your application. But there are a variety of other scenarios where you'll also use delegates. For example, once you get into mapping, when you insert a map into your application, you can assign a delegate to that map in order to influence its behavior. You can control what's being displayed, you can control what sort of interactions are allowed, and when an interaction does happen, the map will then notify the delegate to say that the user has done a tap or that they've swiped or whatever the interaction happens to be. So the way this works is the publisher in iOS sends a message to the delegate to determine whether an action should be taken, inform that an action will be taken, or inform that an action did happen. And you'll find that the message names defined in iOS reflect this purpose. And so often you'll see prefixes on delegate methods such as should, will, and did. And so here on the slide, you can see we have several methods coming into the app delegate. Now let me point out that these are the Apple names for these messages. Xamarin.iOS will sometimes coerce the name to make it a little more .NET-ish or .NET friendly. And so they apply some of the framework naming guidelines and change some of these names slightly. And so as an example, in iOS, you'll find a will finish launching and a did finish launching. Now you saw the did finish launching already. That's our finished launching override in the app delegate class. And so notice there's a slight difference in the name there, but this is the message that's actually being used for the notification itself. So the actual contract that defines the delegate is actually defined by another really interesting feature in iOS called a protocol. The closest analogy in .NET would be an interface. A protocol allows you to define a standard abstract contract of methods and properties independent of the class that implements it. And iOS classes can implement multiple protocols to interact with different things. So Apple refers to this as conforming to the protocol. However, the analogy isn't a complete one-to-one because protocols can define methods and properties which are considered optional to the contract, something that interfaces don't allow. And protocols can define static, we call them class-level operations, which don't require an instance to call them. And that's something that interfaces also don't allow. And so the way Xamarin.iOS sort of works around this is we use abstract classes to to model protocols. And in these class definitions, we use abstract methods for anything that is required, and then we use virtual methods with empty bodies for methods and properties that are considered optional. Now, one thing I want to point out here is because protocols can be optional, so methods and properties can be optional in the protocol, generally speaking, when you're implementing a protocol, which means when you're implementing a delegate, you should not call the base class. And this is a little bit sort of confusing sometimes to .NET developers because we're used to inheritance always calling the base class in order to get whatever the base behavior is. But you shouldn't do this with a protocol because the method may not exist. And it really doesn't exist. It means that there's no handler for that message. And so if iOS gets a call to a base class that doesn't exist, you'll get a method not implemented style exception. So you'll get a runtime exception out of the iOS layer, and your application will be terminated. And so if it's a delegate or a protocol that you're implementing, generally speaking, you do not want to call the base class unless Apple's documentation says it's okay. And so if you ever question whether or not you should call the base class or not, go check Apple's documentation for that particular message and see whether or not it's optional. So let's real quickly test our knowledge just to see how we're doing. So question number 1. What file is responsible for creating the window and listening to operating system events? A, the view controller, B, main storyboard, C, main.cs, or D, appdelegate.cs? And the answer is D, appdelegate.cs. Question number 2. Visual screens can be created through A, a storyboard, B, a zip file, C, code, or D, all of the above. And the answer is D, all of the above. You can create visual screens through any of those approaches. Question number 3. Where can you set application properties such as application name, icons, and launch images? A, assembly info.cs, B, main storyboard, C, info plist, or D, entitlements plist? And the answer is info plist. Remember, this is our application level metadata supplied to the operating system. So now that we've kind of deconstructed the app, let's actually run the app to see what it will do for us. And so we're going to move on to the build process. To compile your code, you're going to use the exact same technique you would for any other app. There's a run button on the toolbar, and there's a build option in the build menu. Or you can use an accelerator key for the hardcore developers that like to do things through the keyboard. Build warnings and errors are going to be reported through the error window just as you might expect. And you can turn that error window on and off using the view menu on both IDEs. So one important note that I want to make about Xamarin Studio if you're using a starter or an indie license. So the iOS project templates for Xamarin Studio turn on profiling by default. And so there's a checkbox in the project options. If you just double click on the project node in your solution, or you right click on it and select properties, either one will get you to this dialog. If you go to the iOS build section, you'll find a checkbox there called enable profiling. And the problem is that if this is checked, then you have to have a business license to be able to use this feature, and you're going to get a compile error if you don't have a business license. The fix for this is to either activate a business license, and that could be a trial, or you could purchase it, or to just simply disable the project in the project settings. So right-click on the project, select properties, or you can double-click on the project node. This will open up the project properties, select iOS build from the list, and then uncheck the enable profiling, and that will get rid of your compiler error. So if you're using the Indie or Starter Edition, be aware of that. So our iOS projects actually have two different build configurations based on whether the code's going to be run on a real device or on the iOS simulator, because the actual runtime environment will change between those two. So the first thing that happens, regardless of what you're going to target, is that the C# source files are going to be compiled to IL using the C# compiler. Then, if you're going to run this on a device, so if you've got the build configuration set to point to a device deployment, then we're going to take that IL, so these generated assemblies, and we're going to create native ARM code because we cannot do JIT on the device. So you may have heard of this. There's a restriction in the hardware itself. Apple actually has a setting set to make it to where you cannot use writable memory pages as executable code. So if you can modify the page in memory, then it cannot be executed. And this is a feature of the hardware that they turn on. And the reason they do this is simply to stop people from buffer overflows and exploits that would let them potentially execute code in your application maliciously. Now, it turns out that this is a feature that you could potentially turn on because Safari does it for some of the JavaScript optimizations. However, the way Apple has it implemented is it requires a specific entitlement from Apple, and so your app has to be signed by Apple to be able to do it. And the allocator for that page only allows you to allocate a single page of code, of executable code from the memory allocator. And so realistically, this will probably never be an option to support a full JIT process on an iOS hardware device. And so what we do is we have a cross compiler that takes your assemblies and it turns it into native ARM code. We call this ahead of time compilation rather than JIT compilation. And it's actually a fairly popular technique that you even see in other platforms. It's very similar, for example, to NGen or .NET Native if you've used either one of those technologies. Then, again, for the device, we take and we link your application to remove anything that's not being used. So if you were to look at all of the stuff that gets included in your app, you'll find that it's quite large because we have to ship the runtime and every assembly that you take a dependency on. And so every framework assembly, every third-party assembly, like for instance if you use JSON.NET or HTTP client or something like that, you're going to end up with those binaries in your actual application because .NET does not ship on iOS devices, and so it has to ship as part of your app. So to try to cut down the size, we have an optimizing linker called CSOL that goes through and analyzes your actual code usage and throws away methods, properties, and classes that you don't use. All right, now this is completely customizable, and if you take the XAM220 publishing class, you'll see how to configure the linker to ignore assemblies or to specifically include certain types. So if you want to really get your app down to the smallest possible publishing entity, then that's exactly what you'll do. You'll go through that process. But the linker will do all that for you. Then we take and we run it through Apple's packaging tools. And so this is where we actually generate the app bundle that's going to be put onto a device. This is done through Apple's publishing tool. And so we use their SDK tools to actually create that final package to make sure that it conforms to whatever specifications they have for it. Now, if you're running a simulator, the process is a little bit different. We can actually do JIT compilation with a simulator because it runs on the Mac, and therefore it's running on an x86 device. As a result, the way it works is we build your assemblies. We do the same C# compiling, either using Microsoft's C# compiler, CSC, or the Mono C# compiler, MCS, depending on what platform you're sitting on. We generate those assemblies and we bundle it with the full Mono runtime. So the real desktop runtime is actually being used, or a variation of it is being used in the simulator. So it's not the same as the runtime that we would use on a device. Now, when you run on the simulator, you have access to all the memory and CPU power of your Mac. And not only that, but you have access to the full JIT processor that's built into the Mono runtime. What that means is your application may run differently on a simulator, both from a performance perspective, but also from a feature perspective. Because devices can't do JIT compilation, that means that there are certain .NET features that are not allowed on a device. For example, reflection.emit is an API that allows you to generate dynamic code. That depends heavily upon a JIT compiler running on the device. We don't have that, and therefore reflection.emit is not allowed. But it would run just fine on a simulator. And so you want to make sure when you do your testing to test it both on the simulator, which is the most convenient and what we're going to do today, but you'll also want to make sure to test it on a device to make sure that it falls within your performance criteria, but also that all of your code paths execute correctly. So on a simulator, we're going to bundle it with the full JIT runtime. We're going to go ahead and package it up with the same APIs that Apple uses, and ultimately that will generate a native application bundle that can be run on the device if that's the configuration, or on the simulator. Now these two pieces, the cross-compiler linker step and the packaging step, are the pieces that run on the build host. And so if you're using Visual Studio, these are the two steps in the build process that are delegated to the Mac. And that means that the native app bundle will actually also be present on the Mac, because we can't execute it on a Windows box. We have to use Apple's simulator or push it to an Apple device, which is also done through Xcode, which is Apple's development environment. So in both of those cases, the actual generated executable will be copied to the Mac, and that's where you'll actually do your final deployment from. We've got our app bundle, and this is always created on the Mac, and if you're building directly on the Mac with Xamarin Studio, then it will just simply be in your bin folder. And there'll be a subdirectory that is the build type that you actually built, and you'll find that it looks like a single file, and it will have a .app extension, but it really is just a folder. And that folder has all of the binaries and assets that are needed for your application to run. And if you right-click on it on a Mac, you can actually say Show Package Contents, and it will actually explore the folder and let you see all the things that are inside of it. This can be useful if for some reason an image isn't showing up or something doesn't look right in the app, and so you want to make sure that it got included in the app structure itself. You can go look at the package contents just to verify that things look the way you expect them to look. But generally speaking, you probably don't care so much about the app folder itself. Now, the structure that's defined here is defined by Apple, and again, it's just being built by Apple's packaging tools. If you're using Visual Studio, then the build host is going to actually create this app bundle for you, and you'll find that it places it into a cache folder. Today it's located at Library Caches Xamarin. And in that folder, you'll find the different builds of your application. And so again, you can switch over to your build host and go explore that package if you need to be able to see what's inside of it. Now, when you go to run the application, you have a couple of options. The first option is we can use the simulator. So this is a simulator included with Xcode. It runs on a Mac. So if you're using Visual Studio, you will need some kind of remote desktop capabilities to the Mac to be able to use its screen, keyboard, and mouse to control the simulator. It can simulate different iOS versions, and you can select different form factors. And so you can simulate, for example, an iPhone 6 Plus or an iPhone 4S. So two different, vastly sized devices on the phone form factor, or you can simulate different tablet styles with different iPad forms as well. You can download older versions of the simulator. So by default, it only includes the latest version of iOS, but you can go into Xcode properties, and there's a downloads section, and you can go download older versions of iOS if you need to test on, say, 7.1 or something like that. And again, if you're using Visual Studio as your build environment, you will need some kind of remote desktop capability like VNC to be able to get to your build host to see the simulator running. The second option is a physical device. So you can connect some iDevice to your Mac with a USB cable, and then both IDEs will see the Mac. So you can see, for instance, on the slide shot on the left marks iPhone. And so my iPhone is plugged into the Mac, and the IDE will see it. I can select that, and it will build the configuration for a physical device. That build will take a little bit longer because remember, it has to do a full native compilation of every code path and then strip all the stuff out that we don't want. And then it will deploy to the device, and it will then run on the physical device itself. In Visual Studio, you have to select the iPhone build configuration. So if you look at the screenshot on the right, notice the middle combo box says iPhone Simulator. I would pull that down and select iPhone. It would just say iPhone, and then it would list my device there as well. And so notice Mark's iPhone is in the list here too, but I would want to make sure to change my build config to be iPhone and not iPhone Simulator. That step happens for you automatically in Xamarin Studio, but it's a separate step in Visual Studio. So if you're using Visual Studio, the IDE just exposes build configurations independently, and you can't force one or the other based upon the device, and so you've got to do that directly. So as I said earlier, you're going to always want to test on a physical device, and this should be one of the steps you do during your development cycle. But testing on a device does require some setup. You have to have some certificates from Apple to sign your application to make them capable of running on a device. And the device itself has to be registered with Apple's developer portal to allow you to install non-App Store apps. So if you're interested in doing this, which you should be, there is a lightning lecture that will walk you through the steps that are required to provision your device and get your application capable of deploying to that device. So make sure to go watch that lightning lecture and then go through those steps, and then you'll be able to do device deployment. So let's run our application on the simulator and try it out. So in Xamarin Studio, the easiest way to do this is to pull down your simulator selection here, pick one of the simulators. I'm going to go ahead and pick iPhone 4S because it's the smallest one and my resolution is rather low right now. And then you can make sure that you have debug selected in the first combo box. So notice I have both debug and release here. And then I can click the play button here in the toolbar. When I click the play button, the application will build, and you can see I get my little status bar up here waiting for the debugger to connect to the iOS simulator. It'll launch the simulator automatically, and then I'll be able to actually run my application. And so I'm going to go ahead and set the scale of the simulator to be a little bit lower, just so we can see the whole simulator on the screen. So my tip calculator comes up, and then you can see I just get a black screen here. That's perfectly fine. That's exactly what we expected to see. Since we haven't put any view into this, the view controller is just creating a blank one, and it just happens to be black. And so our next step will be to actually add controls in here and make this a real application. But let's look at it in Visual Studio real quickly just to see how it differs there. So here's the same code in Visual Studio. We have the same My View controller, and notice I have the same 3 lines of code in my finished launching here. Now in Visual Studio, there's a couple things you're going to want to make sure to do. First, make sure you pull down your build configuration and select iPhone Simulator. Without that, it won't actually run on the simulator itself. And then once you've selected iPhone Simulator, then you'll be able to actually pick the simulator that you want to run on. Now you have to be connected to the build host in order to do this. And so let's make sure that we're connected to a Xamarin Mac agent here. And notice that somehow my machine has been disconnected because it went to sleep. And so I'm going to go ahead and make sure that we're reconnected. Notice that this is just using remote login or SSH now. And so it walks you through the steps of what you have to do on the Mac in order to actually configure that. Once you click OK, it'll show you all the Macs on your network. I'm going to select this one. If it doesn't have a login already, then it will prompt you for your username and your password on that Mac. And then it'll show you a little chain link here to indicate that we're connected. So once we're connected, then what I should be able to do is pull down my dial or my combo box here, and it will show me all the valid simulators that are available on that Mac build host. And so again, I'm going to select iPhone 4S, and then I'm just going to hit the play button here to actually run this. Now remember, in order to actually see the information, I would then have to go log into that Mac that's running the iOS simulator and interact with that screen. And I'm going to want to make sure to log in with the same user ID and password. As it happens, I'm actually on the same Mac right now. I'm just running Windows in a virtual machine, and so you can see that it switched me over to the iOS simulator where it again ran my application successfully. So let's go back to the slides and let's talk about how we're now going to add controls into this application to make this a fully functional tip calculator. So now we've seen the project that we created and we walked through all the source files. We saw the model, the view controller pattern. Remember, the model is the data that we create, which sometimes may just be strings that we have inside of our controller. That's exactly what we're going to do today with our tip calculator. The controller is always something that derives from UI view controller, and it derives the logic of our screens, and the view is a collection of controls that we're going to create, and that's what we're going to look at next. So we've seen the basics of creating the app and how to run it in the simulator, and so now we want to go ahead and add some logic and some new controls into our application to make it a tip calculator. So we're going to do several things. We're going to talk about how you create screens in iOS, and we're going to talk about a couple of again, terms that Apple tends to use, such as superviews and subviews. And so this is really just parent and children, but it's terms that you'll see all over Apple's documentation. We're going to talk about how you can take those views and position them on the screen, and then how we can add new behavior into our application. Now, I mentioned earlier that there's two different ways to be able to create screens in iOS. We can use C# code to create the controls and then add them into the visual layout, or we can use a GUI designer that's built into the IDE to be able to drag and drop and create our screen visually through the design process. We're going to use the code-based approach today because it forces you to understand a bit more about how things are constructed. And so that way you'll understand exactly what's happening when you go through the design process. And in fact, sometimes it's just necessary to do things in code. So dynamic controls that are only created in certain circumstances would be done using code rather than the design process. So the designer is really for static screens where you know exactly what everything's going to look like based upon the data that you have. But the second approach that we have is the designer. And in some ways, the designer actually is a lot easier than what we're going to talk about this morning because it's graphical. But it has its own complexities in managing layout. And so there's actually two classes that you can take in Xamarin University that cover the designer. The first one, and the one you should start with, is IOS102. That'll walk you through the basics of the designer, how it works. You'll get some basics of layout and construction, and you'll be able to reproduce exactly what we do today in code using the designer. The second one is IOS300. This is a more advanced class that covers some of the more intricate elements of the layout process in iOS. And so make sure that you take both of these classes in order to get a full comprehensive view of how the design process works when you're building your iOS applications. The first thing that you need to understand is that when you create iOS screens, they're built as a hierarchy of parent-child relationships. So I told you before that everything that you build visually in iOS is going to derive ultimately from UI view. And that includes the UI window. And so here on the left, you can see a document relationship between all the controls that are visually represented on my screen. At the very root of this tree hierarchy is our UI window. That UI window will always be present, and it's the UI window that we create inside of our app delegate. The UI window always has a single child, which is considered the root of the visual tree itself. To add new controls to the screen, we're going to add new UI view child objects to this root view. And so here you can see we have a text view, and we have a button, and we have a label. Now, Apple calls these children subviews, and the parent is referred to as the super view. And so you can see those relationships here on the screen. And interestingly enough, notice that this relationship extends even into the controls themselves. For example, the UI button has a label child that displays the text for that label. And the text field has a scroll view child that would allow for scrolling if this particular label were large enough to do that. And it has some images that allow it to be able to draw the rounded corners. And so those rounded corners on the text field are actually being drawn through images that the system is just scaling. And so you'll find this sort of super view, subview kind of relationship flowing all the way through. And we call this visual construction of the screen the visual tree for the screen itself. Views are typically managed by view controllers. So remember, your application will always have at least one custom view controller that derives from UI view controller, and it's assigned as the initial view controller that displays the first screen to the user. The view owned by the view controller is called the root view, and it's reachable through a built-in view property. This view is typically created by iOS on your behalf, unless you tell iOS that you want to do it yourself. And notifications are defined as virtual methods on the view controller, and the view then calls those methods at various points in its lifetime to be able to tell the view controller that it's been loaded, or that it's visible or not visible. Now, be aware that this is not a protocol. So this is not a delegate relationship like we saw with app delegate. Instead, this is just a one-to-one relationship between the view controller and the view. So the view controller knows the actual view class, and the view knows about its view controller parent. And so there's not an abstraction between them. They're actually present. They're aware of each other. So one of the interception points that you'll almost always want to react to is the viewDidLoad method. This is called after the root view has been constructed, and it's called once in the lifetime of the view controller itself. Typically, what you'll want to do in this method is all of your initialization code that wasn't done as part of the storyboard design. So either if you're not using a storyboard, like today we aren't, Or if you have some additional dynamic initialization that you need to do independent of the storyboard, then you would want to override this method on your view controller and put that initialization code here. So for example, on the slide here, you can see that we're going to set the background color to yellow for our view. And so let's go ahead and try that in our class itself. So what we want to do is we want to open up our view controller and we want to override the view did load. And then we'll go ahead and pass on to the base. That's fine. This isn't a delegate. It's not a protocol. But what we want to do is go ahead and set the view background color to be UIColor.yellow. So UIColor is a class that just abstracts a color for UIKit, and it's got a whole bunch of properties on it with different colors. So if you'd prefer a different color, you can try some of these others that are in here. Cyan, for example, or you can even use from RGB if you just want to create your own color. We'll do that a bit later. So once you've got this line in here, go ahead and run your app. And so again, I'm going to pick iPhone 4S and run it. It should launch the simulator for me. And now notice that my view has a yellow background. There are other virtual methods on the view controller that you can override to monitor the view lifecycle. So it starts with a method called loadView. This method is called once on the view controller to actually create the root view. And again, normally you wouldn't actually do anything with this method. The system will do it and it will automatically load the view from a storyboard or create the view on your behalf. But if you wanted to create your own custom view that was not a UI view object, instead it was a derived form of one, then you could override that method in order to intercept that process. We then have view did load. Again, this is called once for the view controller's lifetime, and it's a notification that the view has been loaded or created. Then we enter into a cycle, and it starts with view will appear. This is a notification to the view controller to indicate that the view is about to become the active view and present on the screen. That will be followed by a view did appear. This indicates that the view has been rendered to the screen and is now visually present to the user. And then at some point you will see a view will disappear notification. This says that the view is about to be taken off the screen and it's about to be removed from the visual tree. And then finally you'll get a view did disappear. This is a notification that our view has been disconnected from the visual tree. It's no longer the child of the UI window. And typically what that means is that either your app is about to end or some other view has taken its place. For example, if we navigate to a second screen, then we would see a view will disappear and a view did disappear for the existing view, and we would see a view will appear and a view did appear for the new view. All right, so you can use these notifications to kind of track when your view is present or not present as part of the visual tree itself. So we're going to use the view did load method to be able to create our controls and put them into the visual tree. So let's talk about how things are going to be positioned. First of all, you should know that views are always positioned using resolution independent floating point values that we call points. And you position a subview from its top left corner relative to the parent. And so 0, 0 is always the top left corner of the parent view. Now, positive coordinates run to the right for the x coordinate system and run down for the y coordinate system. Negative coordinates run to the left in the x-axis and run up on the y-axis. An interesting thing to note about this is that this is a UI view coordinate system. If you actually do anything with the lower level graphics system of iOS, core graphics, you'll find that it uses a traditional Cartesian coordinate system where the y coordinate runs up and the x coordinate runs to the right. And so it's UIKit that's actually using this particular coordinate system. But this is how we're going to position views. Now, when we do that, there's going to be several properties that we use in order to kind of control where our view is and how large it is. So the one that we care about the most is the frame property. This is a rectangle that defines the x, y, width, and height for the subview defined in superview coordinates. What that means is it's a rectangle defined in the parent coordinate system that is the actual rendering space for the child view. And so if we create a button, for example, its frame would be the frame in the parent coordinate system for where that frame is located and how big it is. The second property that we can use is the center property. This defines the center point for the subview, again in the superview coordinate system. And center and frame are kept synchronized. And so if you change center, then the X and Y of the frame will change in response as well. So the system will automatically keep those two things synchronized. Bounds is the third property. And this one's kind of interesting because it defines the rectangle for the subview in its own coordinate system. And often you're going to find that it looks a little bit like the frame, but it may not be quite as large as the frame because it can be shrunk inwards in order to provide shadow effects or to be able to constrain the rendering of the subview to be a smaller area of what was actually defined in terms of the parent space. You can kind of think of this as the frame is kind of like the picture frame. It defines where we're hanging this picture on the wall, and the bounds is the canvas inside the frame itself. Okay, so it's the inner portion of that frame that we're actually drawing to. The bounds doesn't really care where we are positioned from the perspective of the wall itself. It just cares what's being drawn. And so when you render your content in the control, you'll generally use bounds for that. But when we position the control itself, that's when we use frame. So let me give you a couple of examples. So consider that we have a device which is 480 by 320 pixels. So this is an original iPhone in the landscape orientation. And the top left corner of the view would be 0, 0. And the width and height of the root view would be 480 and 320. If we want to add a subview that's 100 by 100 and we want it centered, then we would calculate the frame to position the top left corner of the subview, and we would set the width and height to be 100, 100. So in this case, we would use the coordinate 190 and 110 for the top left corner of that frame, and 100, 100 for the width and height. Notice that the defined rectangle defines the top left corner and the size, both relative to the superview's coordinate system, so that XY is actually in superview coordinates. The center property is the center point of this subview, also in that parent coordinate system. So since we have a 480 by 320 area, and we've centered this 100 by 100 square in that area, our center point would be 240 by 160. So this is again calculated from the origin of the superview, which again is the top left corner. The bounds is the interesting one, because this is a rectangle that simply defines the view in its own coordinate system. So the 0, 0 point is the top left corner of itself. And so the bounds would be 0, 0, 100, 100. And this is what the subview uses to determine its own dimensions and also how to position its own children. So if this subview has its own children, they would be relative to the bounds coordinate system. That would be their coordinate system that they would be using. Now, iOS is going to keep all of these synchronized, as I mentioned. For example, if you change the center property, then it will change the top left corner of the frame. If you change the bounds properties with the width or height of the bounds, then the height and width of the frame would change as well. So which one do we use? Well, it turns out that you're going to use both of these properties, just in different places. When you're setting a subview's position and size within the parent, then you should always set the frame property. So external to the view itself, you use frame. This is the most common use case, and so you'll tend to rely on frame most of the time. But if you're overriding methods inside the view, then you should prefer the bounds property. For example, it would be the property that we'd want to use if we were overriding the rendering logic, so that we could then render things. And you can see actually that we're using bounds inside our viewDidLoad method here to determine what the current view coordinates are to position our children. So we're using bounds of the root view, but we're setting the frame of the subview. Okay, so bounds is used when you're inside of a method of the view. Frame is used typically when you're outside the method, and it's used strictly for positioning. So let's use a flash quiz to just kind of see where we are. So question number 1. When creating a subview, you should set the A, center property, B, bounds property, C, frame property, or D, rectangle property to set its position and size. So position and size would be the frame. Question number 2. If you change the center property, the frame property will also change. True or false? The answer is true. If you change center, it will change the top left corner of the frame. Question number 3. A frame's 0, 0 is always the top left corner of the screen. True or false? And the answer is false. Remember that the frame's 0, 0 depends upon the view's parent. And so my frame property on a subview is going to be relative to the parent coordinates, which may not be the top left corner of the screen. It's the top left corner of the parent. Now that we've seen how to position a view, let's see what kinds of views we can actually add into our design. So we have a whole bunch of controls that we can leverage, and all of these come from UIKit, which is the GUI framework supplied by iOS. Here you can see a list of the most popular controls that you'll typically depend upon with comparisons to Windows and Android. So if you're a Windows developer or an Android developer, you can kind of use this list to sort of compare some of the things that are available. Now be aware this is not a complete list. This is a very small subset of all the controls that you actually have available to you. The ones that we're going to be using today are these 3: UI button, UI label, and UI text field. So button displays a tappable button that the user can use to cause some action to happen. A label is a piece of read-only text on the screen, and a UI text field is a read-write field, so one that puts up an on-display keyboard and lets the user type in some sort of prompt. So what we want to build is a tip calculator application, and this is the UI that we want to create. We need 3 controls here. We're going to use a UI text field at the top to hold the total price that we want to calculate a tip for. We'll then place a button below that to actually calculate the tip. That will drive the logic, so when we tap the button, it will read the value from the field, calculate the tip internally, and display the results in a label that's positioned just below the button. Now, here's how we're going to do it. We're going to add these controls into our view hierarchy. The way that we do that is first we need to create each control. So the entry field is created by creating a new object of type UI text field. So notice that there's several things that we can set here. First, we're going to set the frame. You almost always will set the frame of every control you create because that's what positions and sizes the control. Remember, it's done in super view coordinates, so it's always done based on parent coordinates. In this case, we're going to position it 10 points from the left, 20 points down from the top, and we're going to go ahead and take up the entire width of the view minus 20, so that's going to account for 10 points on the left and right, and we're going to make it 35 points high. Then we have a couple of other properties we can set. The keyboard type property allows us to control the keyboard that's going to be displayed when you tap in the edit field. There's a whole bunch of different styles you have available to you. We're using email address here. That won't be what you actually use in the lab, but we have other types such as phone pad, number pad, URL, default for just a general keyboard, that kind of thing. You can also set a border style. The border style is what allows you to control whether or not it's a square border or maybe an invisible border, or in this case a rounded rectangle around the text field itself. And then we're setting a placeholder property here to display some light gray text in the field. And so in this case we just want to display the word email address. That allows us to not have to put a label above the field to tell the user what we're looking for. Instead, it's a prompt right there within the field. When they tap on the field, it gets replaced with whatever they type. You're going to create an entry field for the tip calculator, and so you'll probably want to use a number pad keyboard style, and you'll want to use a placeholder that says something like enter total amount or something along those lines. The second thing that we need is a button. So the button itself is created through the built-in UI button class. The constructor for UI button, and there are several constructors, but the one that we're highlighting here actually takes the type of button you want to create. And so there are several different types of buttons. We have an info button that displays like a little eye with a circle around it. There's an info dark button that changes the theme of that. There's a standard button, which is just the text with no border and no background. Or you can create a custom button. That's what we're doing here. And again, we're going to set the frame, and because it's a custom button, we can control the background color. And so we're going to set the background color to a red color. So notice we're using a method here called UIColor.FromRGB. This is a static method on the UIColor class. UIColor is the class that we use to represent colors in UIKit. And FromRGB is just a static method that lets you supply a red, green, and blue component. In this case, we're actually setting it to be a dark red color. So the red, green, and blue components are specified as a 0 to 1 range. And since we're only setting the red component and we're setting it to be 0.5 and everything else is black, then it will be a dark red that's being displayed. Then the last thing that we do here is we have to set the title for the button. So it's a little interesting in iOS because they don't have a property to set the button's title. And there's not like a text property. Instead, when you set the text on a button, you actually can set the text independently for each of the states of the button. And so in this case, we're setting the button state normal, and we're setting the text login in this case. You're going to want to set it to calculate tip or something along those lines. If you set the normal state, then it sets all the other states as well. But if you want to, you can actually change the text when the button is being pressed, or you can change the text when it's disabled. So you can have different text on there based upon the state of the button, which is kind of interesting and a little unique to iOS because I'm not aware of other frameworks that do that without you deliberately doing it programmatically. And then finally, we'll want to add a label. So a label is a piece of read-only text, and we do that by creating a UI label class. Notice that we're passing in the frame to the constructor in this particular case, and this is actually something you do for most of the controls, with the exception of button. Button does have a constructor like that, but then you can't make it a custom button if you do that. You could have done this with the entry field as an example. You could have passed the frame on the constructor. Or you can just set the property. It does exactly the same thing. It doesn't matter which approach you take, you just need to make sure to set the frame. Then we're going to set 3 other properties. Text, to be able to set the text that we want to display. Text alignment, to decide how the text is aligned. In this case, we want it to center within its frame. And so we define the frame for the button. That ultimately will set the bounds. And then by setting the text alignment, you're centering the text within the boundaries of where it renders. And then we're setting the text color. In this case, again, we're going to use our UI color class, but we're going to use a different static property on it this time called blue. So UI color has several colors that are predefined on it: blue, green, red, yellow, that kind of thing. And so we're just going to use the built-in blue color. And so you can use a custom color with from RGB, or you can just use one of the built-in colors if you choose. Now, once we've created those controls, then we need to add them into our view hierarchy. The way we do that is by calling a method on the root view itself. So UI view has the ability to support a collection of children. So every UI view can have multiple children in it. The only exception to that is UI window. So UI window only wants one child, the root view. But the views that you add after that can have multiple children. So notice that we have a couple different ways we can do this. In this slide, we're using the add subview method. This is a method that's exposed directly on the view from iOS, and you pass in a single view that you want to add to the children collection. If you have multiple views, then you can use add subviews, and then you pass in each one of the controls you want to add. Now, these are the methods that are exposed by iOS. It turns out that Xamarin.iOS adds onto this an add method, both at the view level, so you can see there's a comment between those two methods, view.add label. This is an alternative approach. And there's also an add method on the view controller, which will then delegate down to its root view and add the view to the root view. So either one of those would work as well. And you might ask, well, why in the world did Xamarin.iOS add in an add method when there was already an add subview? Well, the reason is because C# will do something interesting with add methods. It allows you to do collection initializer syntax. And so you can create a view and add all of its children in a single statement using a collection initializer in C# as long as the control has an add method and it's IEnumerable. If those two conditions are met, then C# allows for that particular syntax to be used. And so this is why Xamarin.iOS adds in an add method. Number one, because it's just a more familiar paradigm for .NET developers. They expect to see an add method. But number two, because it allows for that sort of syntax. And so just be aware of that. And so I mentioned that it has to be IEnumerable. Well, it turns out that views are also IEnumerable, specifically to support that case. And so you can enumerate with a for each a view, and that will let you walk through all the children that have been added to that view. And as an example here in this particular code snippet, we're going to remove a child from the view hierarchy. And so we do that by calling remove from superview on the subview itself. Now, this is kind of interesting because we do the adding on the root view. So the super view is where we add the view child. So we call add subview or just add on the parent, and then we pass in the child. But when you want to remove the child, you call a method on the child itself. All right, so let's go ahead and create the UI for our tip calculator by adding in a text field, a button, and a label into our view. So we want to actually add the UI into our application. That's exercise number 4 here, create the UI for the tip calculator. If you open this up, this will take about 15 minutes, and your goal really is to create this UI right here. This is a UI text field at the top. It's got a 28-point margin from the top of the phone device itself, and its height is 35 points. And then there's an 8-point margin between it and the button, and then the button and the label. The button itself is 45 points high, and the label is 40 points high. And then each one of them is stretched across the entire view. So there's a 20-point border from the left side of the screen and the right side of the screen to the edge of this. And so you can use those dimensions in order to calculate the rectangle that you'll need to set for the frame for each one of these items. You can use these instructions down below to actually walk you through all the pieces. And so it'll tell you what to name each field and then what you want to set it to. And then it'll tell you what properties to set. Or if you'd like to, you can just experiment and set the properties to different things just to try it out. So go ahead and pause the video here and then use this visual image to be able to create this UI right here and get it visible in the simulator. When you come back, we'll go and add this code in together into our application. So here I am in our view controller, and this is exactly where I'm going to add my controls. ViewDidLoad's a great place to initialize the view and add whatever things you need to be able to get the screen looking the way you want it to before it's displayed the first time. We want to add our 3 elements in here, the UI text field, the UI button, and our UI label. So let's start with the UI text field. I'm going to create a new UI text field. We'll call it total amount. So we're just going to create a new UI text field. And I want to go ahead and pass in a frame to be able to control how large this is. Remember, you can pass this in on the constructor, or you can use a property. So you can use the default constructor there if you choose and just set it as a property. But I'm going to go ahead and pass it in on the constructor. So let's go ahead and create a new CG rect. And remember what we wanted here was we wanted this to be 20 points from the left, so my left will be 20, and I want it to be 28 from the top, so my top will be 28. Remember, my parent view is going to actually be the main UI view that's controlled by the screen. All right, so the one that's owned by the window itself. So it's going to be the whole screen itself. Then what I want is I want to set my width to be the size of the screen minus 20 for the left edge and 20 for the right edge. And so to get to that, I'm going to use view.bounds. Remember, view is the property that represents the top level view or the root view for this view controller. And I'm just going to subtract 40 from that in order to create my boundaries on both sides. And then we would just want the height for this to be 35. Then let's go ahead and set some properties on this. So we want to go ahead and set the keyboard type. We're going to make that a UI keyboard type .decimal. And so I want to be able to enter decimal values in here. I want to go ahead and set the border style for this to be UI text border style. And we'll go ahead and set it to be a rounded rect. And then finally, let's go ahead and set our placeholder text. And let's just make that enter total amount. And so that'll be my first control that we're actually creating here. Then I want to go ahead and create a button. So let's call this calc button. And remember, we can create different styles of buttons. And so notice my button types can be a contact add, detail disclosure, info dark, info light, a rounded rect. That's an old deprecated form that's basically just the same as default or system. And then I've got custom here. And so we're going to use custom because I want to add in a background color. And we want to go ahead and set some properties on this. And so the first property that we're absolutely going to have to set is the frame. So let's set frame, CG rect. And again, I want it to be 20 points from the left. I want it to be 71 from the top. So what I'm calculating here is how big is this text field here? We know it's positioned at 28 and we know it goes for 35, and I know that I want it to be 8 points down below that. If we add all that up, it ends up being 71. But you could, if you wanted to, say 28 plus 35 plus 8 in order to get the same value. I'm going to do the math, even though it would automatically do it for me if I did it that way. And I'm going to do the same thing here, view bounds width minus 40. And remember, we want this to be 45 points in height. Then I want to go ahead and set my background color. We're going to set that to UI color from RGB, and I want it to be kind of a dark green. So we'll make red 0, green the half color, and then blue 0. And so that'll be essentially a dark green color for my button itself. And that's all we need to do for the button. Now, we have one more item that we want to set on the button, but we can't do it through a property. Instead, we have to use, if you remember from the slides, the set title method. And so we'll set it to calculate, and I'm just going to set the UI control state to be normal. But notice that we have others here. I can set it for disabled, I can set it for selected, but by setting normal, you'll actually end up setting all those other states as well. And it looks like I misspelled calc button, so let me just make sure that that gets spelled correctly. The last control that we want here is the label itself, the result label. And so we'll say new UI label. I want to create a new CG rect for my frame. And in this case, I'm just going to go ahead and let it stretch all the way across. But if you want to, you can use 20 and view bounds width minus 40 as well. I want it to be at 124. And then I'll just say view bounds width. And we're going to make it 40 points in height. Then let's go ahead and put in some properties on it. So I want to go ahead and set a text color. Let's just make it UI color blue. I want to go ahead and set a text alignment. So if you remember from the slide, that lets me align the text itself. We'll just go ahead and center that. I want to go ahead and set the font for this. And we'll just set this to system font of size. And let's just go ahead and make it a 24-point font. And then let's set the text. Tip is, and I'll just initialize it to 0. Now, we've got all our controls created. Now I need to actually add them into my view. So remember, we have a couple ways we could do that. I could say view.add and then add in a view. I could just say this.add. That does exactly the same thing. It adds the view to the root views collection. Or you can say view.add subview, and I can add in a view one at a time. Or we can do what I'm going to do here, which is add subviews, where I can just pass in a list of UI views. So I'm going to put them in the order that I want them drawn. In this case, they're not overlapping, so it won't really matter. But we'll set it to total amount, calc button, and result label. Once I've got all this set, I can then run my app. It'll again run it in the simulator, hopefully. Oh, looks like I have an error here. And it says operator minus can only be used, so I didn't put width in there, sorry. Missed width. Let me just pull this back just a little bit. So we can't subtract from bounds itself, that's a rectangle. I have to subtract from the width of the bounds. Simulator comes up. Let's go ahead and set our scale. And then notice that I get my tip calculator. If I tap in the edit field, notice that I get a calculator here. I can say 250.85, and I could click my calculate button, but it's not doing anything because we don't have any logic behind this. So notice that when I click on the calculate button, or even if I do anything else in here, my keyboard stays present. In fact, the cursor is even just staying inside the text field here. So let's go back to the slides and let's talk about first how we can fix this, and then second, how we can add some behavior in this application and actually make it a real tip calculator. So now that we've added in our view, one thing that you might have noticed as I went through that is that the keyboard is automatically displayed when I tap the UI text field. But it was not dismissed when I click the calculate button or if I tap on a label or something else. And the cursor just stays inside the text field. The reason for this is because in iOS, touch events are delivered through what they call a responder chain. And that decides which control should handle touch events when they occur. The control that handles the touch event becomes what iOS calls the first responder. So this is, again, terminology that Apple defines. And it's essentially managing the focus chain. So if you want the equivalent in Windows or Android, that's kind of what Windows and Android would term that. Now, once a text field becomes the first responder, then it displays the on-screen keyboard. So that's why the on-screen keyboard came up, because the text field became the first responder. But it doesn't dismiss that keyboard until another control becomes first responder. And the problem is that buttons and labels never request to become the first responder. They handle a tap, but they don't actually request the focus input, and therefore they don't take that first responder status away from the text field. And as a result, the text field doesn't go away. So in order to dismiss the text field, you have to be deliberate and call a method called resign first responder on the text field itself. Now you can do this in a variety of places. Often what we'll do is there are some events you can hook into to catch, like if the keyboard has a return button or a done key, you can catch those and then you can get rid of the keyboard at that point. Or you may want to do it, in this particular app, we probably want to do it when we hit the calculate tip button. And so we would just call resign first responder as part of the calculate tip logic in order to get rid of the keyboard and then display our results. Here we can see we're just calling a method called hide keyboard, and then we call resign first responder there. So again, you can do it in a variety of places, but the key point is you have to call this method in order to get rid of the keyboard. The other thing that you may be thinking about is the actual views that we created. So we've created 3 controls and we've added them into our view. In this case, the views are relatively small and they're not really significant from a memory perspective. However, some views actually are quite a bit larger. For example, images can hold on to large blocks of native iOS memory that the GC process, the garbage collector, is completely unaware of because it's only known to iOS itself. And so that can cause memory pressure on your application because you're holding on to these images. And the problem is that GC doesn't realize that it's the image that's actually causing that. So it won't be in a big hurry to throw away the image because it looks at the image object and it just sees a very small managed wrapper representation for that image view. And so what you want to make sure to do if you're holding on to these expensive things is you want to go ahead and use the dispose pattern. And Xamarin.iOS incorporates that pattern into the view controller itself. And so you'll find that there's an overridable method on the view controller called dispose that passes you a Boolean indicating whether or not we're currently disposing or if we're in the finalizer of the garbage collector. You really only want to do this work if that Boolean is true. Okay, so if the Boolean is false, it means that you're being collected, and generally speaking, it means that you only can touch native resources at that point. So managed things are off limits. Don't touch C# objects. All right, so if the Boolean is true, it means that dispose is really being called. And in this case, you want to take things like images and you want to call dispose on them. And then you can go ahead and set the field to null to make sure that the garbage collector can see that there's absolutely no reference to this and it decouples the lifetime of the view controller from the image itself. Dispose is called on the view controller when the view controller is actually going away. All right, so this will be one of the last things you see on a view controller before it's physically removed from memory. And so this is your moment to clean things up. And again, you only want to touch managed things. And so if you're holding on to large resources or things that are scarce, like for instance, maybe you hold a database connection live, or maybe you have a web service connection or something like that you're holding on to, you can release those sorts of things here by calling dispose on them as well. And so anything that's disposable, I would just look at things that you're holding on to that you have live references to in your view controller and then get rid of those by calling dispose. So now that we have our UI, the next step is to add some behavior. So iOS sends messages from the UI view, that is the control, to any interested party that wants to know about user interaction that happens to be occurring. And Xamarin.iOS hooks into this system and it exposes these messages as .NET events. And so you handle them as traditional .NET events. And here's a couple of examples shown here. So touch up inside on a button is used to indicate that the user has tapped on the button boundaries. And so this is where we'd want to actually handle our button click. And so in our tip calculator, we're going to want to handle that calculate tip button by handling the touch up inside method. Here's a couple other examples. On entry controls, we have a set of events, editing did begin, value changed, and editing did end, to indicate that we've started editing and the keyboard's been shown, the value's been changed in the edit box itself, and so this happens each time you type in the edit box, and the editing did end to indicate that we've resigned first responder status and the keyboard potentially has gone away, although it may not physically go away because we may have moved it to another edit control. All right, but it indicates that the current edit control has lost the input focus. Since these are normal .NET events, you can use any event handling technique you like to be able to process them. So in this case here, we're wiring up anonymous methods, but you could use lambda expressions or even just point it at a method as long as it conforms to the signature. Notice that in this particular case, all of them are just the standard event handler signature of object sender and event args. But some events are exposed with more customized event args types, where they have specific things or information that needs to be passed along with the event that's relevant to it. So the event handler is going to be placed in the view controller code itself, and you're typically going to want to place the event handler, or at least wire it up, in your view did load method. So in this case here, you can see we're wiring up our button, touch up inside, to an on login button clicked, and then we've got some method defined in the view controller to actually handle that. We could either do the processing logic in that method, or if I had some specific model objects that were created to kind of process some of this logic, I might then call out into a model object to be able to do some of that. It just depends upon how complex the logic is. But remember, our view controller is sort of the collector. So when we get the login button clicked, it would collect all the things that it needs from the UI views, and then it would pass those into the model and then pull any results back out of that model and then push them back into the UI itself. How you construct that from a code perspective is completely up to you, right? That's just the pattern of architecture, but you could put all that code right here in the view controller if you choose. And so there's no set way to actually there's no right way to do it, I should say it that way. Instead, it really is just more of a personal preference about how you like to structure things, what's going to be best maintainable for you going forward in the future, and how much reuse you really want to get out of this, right? So clearly you're going to get more reuse if you move it into its own class. But you can put it right here as well. So let's go ahead and do that. Let's add our tip calculator logic into the application. So in our start here, we're going to go to the very bottom here to exercise number 5, adding logic to the tip calculator. If I open this exercise, this is another relatively short exercise. And the idea is that you're going to handle the touch up inside event on your calc button. When you see that event occur, you want to go get the total amount from the UI text field and multiply it by 20%. Take the value that you get out of this multiplication and simply set the text of the result label. So ultimately what we want to have happen is when I type $125.40 into the text field and click calculate, I want to see the text tip is $25.08. So go ahead and stop the video here and work on the exercise and get it working. And then when you come back, we'll just walk through that code together. So here I am back in my view controller, and this is the code that we left off with. And our goal is to now add in event handler for calc button. We can put it anywhere in here, but generally speaking, you're going to want to put it somewhere in your view did load. And in fact, for this particular implementation, we would have to put it somewhere in here because that's the only method that has access to this particular field. So if I wanted to put it outside of here, I'd have to move this field out to make it accessible anyway. So I'm just going to put it here at the bottom. And we'll just say calc button, touch up inside, plus equal, and I can use any form of event handler here. The most convenient right here would either be an anonymous method or a lambda expression, just because all of my fields have been created inside of this viewDidLoad method. But when you do the homework a little bit later, you'll have to move all these fields into class fields to be able to access them outside. But we'll just use a lambda in this particular case. And so I'm just going to get the button sender and an empty event args here. And my goal here is to go ahead and first dismiss the keyboard. And then I want to go ahead and get the value from the total amount text field, multiply it by 20%, and take that value and then put it into the result label. And so let's first dismiss the text field itself. Remember, to do that, I want to go to the total amount text field and I want to call resign first responder. That will get rid of the keyboard and cause the keyboard to actually be dismissed. Then I want to go ahead and get the value that's in that text field, and so we're going to go ahead and use double.tryParse. And we'll go ahead and say total amount.text and out value. Now this returns me a Boolean, but I really don't care if it worked or not. If it doesn't work, then it just sets value to 0. And so my value will be 0, which is what I want to display in the label anyway. And so there's really no need for me to test the result value here. But what we want to do is we want to go ahead and set that to the text of the result label. And I'm going to use a cool, nifty C#6 feature here and just say tip is, and then we can say value :C. And so what that does is that essentially does a string format where value is passed in as the 0 parameter, and then it formats it with currency here by using the :C. So this is a nifty trick, which is just a C#6 feature that's available to us. Now, right now, we're actually taking this value and we're just applying it to it. But what we really want to do is we want to say value is equal to value times 0.2, right? So I want to actually multiply this by 20% in order to get my final value that I'm going to display inside the result label itself. And interestingly enough, notice the IDE has a little bit of a bug here. We are actually using the value, it's right here, but it's showing this in a light gray, sort of indicating that it doesn't think the value's in use. All right, so let's go ahead and run this and see how it works. So it comes up in my simulator. I'm going to type in 125.80 and hit calculate, and I get $25.16, which should be 20% of this amount. My keyboard gets dismissed. Everything's working the way I expect it to. Hopefully you had the same experience in your lab. So now you've seen how we construct screens. You've seen the basics of positioning views using frames in code. We've seen the life cycle of the view controller and how it controls that root view. And you've seen then how to interact with those controls. So how we can wire up event handlers to be able to respond to particular interactions from the user itself. The next class in this sequence would be IOS102. In IOS102, you're going to go through the designer side of this. And so you're going to construct another application, but you're going to do it completely through the design surface, using drag and drop and being able to position things on the screen using the designer. But all the things that you learned here carry forward in that. So when you move things around on the design surface, you're really adjusting the frame of that view. And when you drop something onto the design surface, you're adding it into the view child collection of the root view on the screen itself. And so all the things that we did here programmatically will then correspond to things being done in the designer. So that's your next step. Now there is a homework assignment with this class where you can continue kind of practicing your skills by adding some additional logic into that tip calculator. So go to your Start Here file and go check the homework assignment and see how to then construct that. Now, the homework assignment is a little bit different than the other labs. We don't give you the step-by-step instructions. Instead, you're just given the high-level goals of the homework assignment, and then you use the slides and the information presented in this class to be able to complete that assignment on your own. There is a completed project there, so you can check your work using the completed solution. So good luck and have fun with that. So thank you for attending iOS 101, an introduction to Xamarin.iOS. I hope this class has been informative in showing you the basics of how to actually build Xamarin.iOS applications. If you have any questions, please feel free to email me. Again, my name is Mark Smith, and my email address was on the very first slide. Thank you, and have a great day.